The Sun is the closest star to the Earth. The Sun is a giant plasma ball, inside which thermonuclear reactions take place. It is located at a distance of almost 150 million kilometers from us. Its surface temperature is 5,780 degrees Kelvin. The mass of the Sun is 500 times greater than that of all the planets around it. The Sun makes up 99.866% of the mass of the solar system. This means that it weighs about 500 times more than all the planets and asteroids combined. Even the mass of Jupiter is only 1,000th of the mass of our luminary. As for the Earth, it is about 333,000 times lighter than the Sun. Our luminary could hold 1.3 million terrestrial planets inside. At the same time, the density of our star is about 40% higher than that of water. The Sun has a crown. The solar corona, Latin for crown, is the outer layer of our luminary. It consists of protuberances and various plasma eruptions. Usually these formations are hundreds of thousands of kilometers long. For examples, they are longer than the distance from the Earth to the Moon. The solar corona is one of the hottest parts of our world. Its average temperature is 1 to 2 million Kelvin. However, sometimes there are some even hotter spots in it, the temperature of which can reach 20 million Kelvin. The solar corona can be seen from Earth by observing our luminary during its total eclipse. There are spots on the Sun. Sunspots are areas on the surface of the Sun where the lines of force of its magnetic field are twisted and torn. The layer of the Sun's surface that emits visible light is called the photosphere. There are colder areas that seem dark. You can't just look at our luminary through a telescope, but if you use dark filters, large groups of spots are visible. Solar wind can cause magnetic storms on Earth. The Sun's magnetic field is constantly accelerating charged particles called the solar wind. Usually its intensity is too weak to harm people on Earth. But during solar flares, a large number of charged particles can be emitted. Sometimes a large piece of plasma can even break away from our star. This phenomenon is called coronary ejection. When such particles or plasma reach our planet, they interact with its magnetic field and atmosphere. Such storms can cause failures of electrical and radio equipment and indispose people with chronic diseases. Total eclipse of the Sun occurs when the Moon obscures our luminary completely. There are also partial and annular eclipses. The latter are observed when our natural satellite is in the far part of its orbit and its disk becomes too small to cover the whole of the Sun. In about 600 million years, total solar eclipses will stop occurring. The Moon will gradually move away from us to a distance at which it will always look smaller than the Sun. Then only partial and annular eclipses will be observed. The Sun's radiation is growing. The radiation intensity of our luminary is slowly increasing. When it was born 4.5 billion years ago, it was about 25% dimmer than it is now. Since then, its brightness has gradually increased. It is possible that in 1 billion years life on Earth will become impossible due to the growing luminosity of the Sun. Other studies show that this will happen in 3.5 billion years. The Sun will become a red giant. At the age of 10.9 billion years, the Sun's core will start getting depleted of hydrogen. Our star will swell, and in a few hundred million years it will turn into a subgiant, an orange star, whose radius will be 2.3 times larger than today. At the age of 12.2 billion years, a thermonuclear reaction will begin in the outer layers of the Sun, and it will start swelling even more. Our luminary will turn into a red giant and absorb the inner planets. These transformations will end with the outer layers of the red giant flying into space, and the inner ones shrinking down to the state of a white dwarf. Without the Sun, there would be no life on Earth. It would be too cold for animals to live, and plants need sunlight to create their food. The Sun also causes the seasons, currents in the oceans, weather and climates. Did you know? Every planet in the solar system can fit between the Earth and the Moon, but Sun can't. Even 1/3 of Sun would be too big to fit. Light from the Sun take 8 minutes and 20 seconds to reach planet Earth. Did you know? The Sun isn't yellow, it's white. We see it as a particular color because of the light that's able to pass through the atmosphere. Most photos of Sun have been altered to be the color that we are used to seeing, but in space it's just white. If you pour a bucket of liquid water of size equal to that of Sun on Sun, the water added will evaporate immediately due to heat of Sun. The added water will increase the mass of Sun. The Sun will form a new kind of star, mass 1.7 times its original mass, containing 48% hydrogen, 37% oxygen and 14% helium, and start emitting white blush light. The heat output of Sun would increase, and that would fry the life on Earth. Did you know? A solar eclipse helped end a 6-year war in 585 BCE, when the sky suddenly darkened during a battle between the Lydians and the Medes in modern Turkey. Soldiers took it as a sign to cease fight. Also, vitamin D doesn't come from the Sun, it comes from our skin. Sunlight is the factor that converts cholesterol in our skin to vitamin D3. Earth receives 94 billion megawatts energy from Sun.